Okay, hello, welcome everyone. New year and a new event series, and we're very happy to kick off Spring 2024 in the NZES Social Science Data Lab with a talk by Asya Magazinnik, who's joining us here today, entitled Models All the Way Down. My name is Dennis Cohen. I am co-organizing the Social Science Data Lab with Alexander Wenz, and I'd briefly like to introduce Asya a bit further. She's professor of social data science at the Hertie School in Berlin, and her research interests include the intersection of federalism and democratic representation, formal theory and causal inference methodologies, as well as the measurement of political preferences. In her talk today, Asya will present some snapshots from a larger book project co-authored with Scott Abramson and Koran Kozak that describes the connections between the Neyman-Rubin causal model, the basic estimands of randomized control trials, targeting respondents' preferences, and the theoretical object that is traditionally described as a preference. Before we start, just a couple of words on the logistics of today's talk. As we usually do, we are recording the session. We're doing so in active speaker mode, which means the audio from our on-site participants will be recorded if you ask questions, and if you're online and asking questions, your audio and or video will be recorded once you unmute yourselves and speak. If you want to avoid having your audio and or video recorded, feel free to post your questions in the Zoom chat, in which case I, as moderator, will read them out for you. With that being said, Asya, we are very happy that you're here today. We look forward to your talk, and the floor is yours.
Great. Thank you all for having me. I'm very excited to be here. So this is a talk called Models All the Way Down. And it's, you'll bear with me, it's as Dennis said, just some snapshots from a larger project. But we want in this project to place some theoretical scaffolding under the commonly used statistical methodologies for measuring political preferences. So I put political in parentheses here because I'm a political scientist. Of course, I'm interested in political preferences, but the real kind of nature, the heart of the issue is not the political nature of the problem so much as the multidimensionality of the problem, which I think characterizes many political choices, right? So when a voter decides between different candidates, they're thinking about issues, they're thinking about personal characteristics of that candidate, they're thinking about partisanship, and they're trading off all of these considerations. Distributional questions are kind of by their nature multidimensional. They have as many dimensions as there are parties or interests vying for the resource, right? So that's what we have in mind. And as you'll see in the talk, the multidimensionality is really what introduces the complexity that we're trying to address. But the key takeaway of the talk is that causally identified quantities of interest, which is what we tend to focus on in our experimental designs, are not necessarily the same as statements about preferences. And so today in this talk, the talk will have three parts. In the first, I'm going to start talking about what we might mean by preferences, kind of what we colloquially mean, what political scientists want to say, and then how we can formally model that. Then I'm going to illustrate why this object may not align with a very intuitive causal quantity. So in some other work with my co-authors, we've shown that the kind of a very common estimand used in conjoint experiments, the AMCE, does not align with a majority preference. And here we're making an even broader statement. We're saying that it's not because the AMCE is necessarily a weird or complicated quantity. In fact, just back up to a simple average treatment effect from a very sort of straightforward randomized experiment. Even that is not guaranteed to correspond to what we define as a preference. And I'll give you an example. And then we propose a way forward. So in the larger book project, we're going to think about a lot of different ways forward, and this is just one of them, which is to propose a research design that starts with what you think of as a preference and go from there, right? And design an experiment to identify that object. And how you do so is going to depend on the very particular electoral context in which you're operating. That's going to depend on the issues you care about. And I'll give an illustration. Okay, and kind of in the background of this is a really nice theoretical structure that is proposed by Ashworth, Berry, and Buena de Mesquita in their recent book, Theory and Credibility. So they kind of give us a blueprint for what the role of theory should be in empirical work. And kind of, not intentionally, but my co-authors and I were, I think at the same time, kind of operating within a very similar framework. But what they say is, over here on the left, we have some theoretical process, some theory that the analyst might have. And from that theory, they develop an ideal quantity of interest. Right, and in going from that theory at the individual level to some aggregate quantity of interest, we have to worry about aggregation problems. The social choice literature has a lot to say about that. But all of that is the sort of ideal. This is what we're this is sort of what we're searching for as analysts. And then over here on the right is what we can actually achieve with data, right? So we have some research design. We propose an estimand that we can compute from our data. And here there are all kinds of problems of estimation that especially people in the conjoint literature, in the preference solicitation literature, have thought quite a lot about. But we would argue that while a lot of time has been spent over here on the right, this left side has been more neglected. Right? And there's this very important arrow in between, which Ashworth et al. Call commensurability. But it's basically, does your estimand correspond to your quantity of interest? Right? So you could have done everything right over here. You could have estimated you could have had your estimand perhaps very precisely estimated. You could have an unbiased estimate, but that doesn't guarantee that it corresponds to this quantity of interest from theory over here. So that's kind of the general framework in which we're operating. So we're going to think about this commensurability problem. But first, what is a preference? Right? So how do we think about these things? So let's start with a choice set. So here we have 4 objects in our choice set, A, B, C, D. And we're going to say for any 2 members of this set, we can define a preference relation. So somebody can either prefer A to B, they can prefer B to A, they can be indifferent between the 2. The only thing we rule out is that they can't decide, which is different from being indifferent. Right, and we can define this binary preference relation for every 2 members of this set. So in a political context, we might have Donald Trump and Joe Biden. Right, we might have tax plan A and tax plan B. But as social scientists, we're probably not most of the time interested in this particular choice between tax plan A and tax plan B, or these particular 2 candidates, right? I mean, unless we're doing unless we're projecting winners of elections, which is also very cool, right? But often as social scientists, we're interested in zooming out from that and making more general statements, right? So we might want to ask, is there a systematic bias against women or racial minorities in the electoral process? We might be interested in descriptive representation, right? So whether voters want to elect somebody generally like them or who shares certain attributes. And then we might be interested in how voters trade off different characteristics of candidates, right? So their issue positions versus their personal attributes versus their party, right? These questions all follow from the multidimensionality of real world choices, but we might actually want to say something about kind of these broader categories, not specifically Donald Trump or Joe Biden, but about different racial categories, about different issue positions, about different parties, which all requires some generalization, right? So how do we go from there, right? How do we build something like a preference over attributes? So we propose 2 possibilities, right? So one way that we could do this is we could start we could kind of define our primitives over candidates. So in this case, over a particular candidate for political office. Right, and this candidate is kind of defined by certain characteristics. And then we can look over multiple candidates, multiple choices, and summarize. On the other hand, we can define primitives over the attributes themselves. We could say voters have some clearly defined preferences about age, about gender, kind of first order preferences about these things. And then preferences over candidates or bundles of these attributes are built up from there. Right, so we could go kind of one of two ways, and I'll show you in more detail how each one would look. Right, so let's start with the first one. Let's say preferences are defined over kind of profiles, right, or over people. And so we have two candidates. This is, Republican candidates, and we have, and they have some attributes, and we can show this to a voter, and a voter can choose which one they prefer. And if we're interested in saying something about whether voters are biased against women, let's say, how would we do this, right? So we have one specific female candidate that we can compare to Donald Trump, right? We could say, okay, well, we need to generalize a little bit more than this one person. Maybe we can build an alternative candidate who looks very similar to our first candidate, Nikki Haley, but we'll change her race. Maybe we'll change some other features. Maybe we want to change some features of Donald Trump, right? So as we generalize, we kind of vary different attributes other than gender, right? And so broadly, the way we would do this is we would fix gender as male for candidate 1 and as female for candidate 2. And then we can kind of randomize all of these other attributes, or we don't even have to randomize, right? Like we could consider every other possibility, show this to voters and ask them to compare the two and tell us which they prefer. And then we can compute the proportion of those comparisons in which a voter chooses the female candidate. Right, so that seems like a somewhat intuitive definition of a preference, the proportion of binary comparisons in which the voter picks the male over the female candidate, right? The downside, I'm just going to move this because this is an important point, right? So the downside is this is very sensitive to the distribution of the other attributes, which is also true of the marginal component effect, right? So it turns out that the values of party, the values of race that you include, and which other attributes you include are going to change the proportion that you come up with in these binary comparisons. But there's nothing we can do about that, right? So we still kind of propose this one definition of a preference, which is this aggregation over binary comparisons between two candidates.
Allowed to ask questions?
Please, yes, I'd like that.
Okay, so why, it seems that you try to construct something like a utility function without naming it a utility function.
But I'm about to actually do that.
Oh, I'm sorry.
No, but this is not that.
Okay.
Right, because this
I wonder about that.
Yes,
why
yes.
you don't do this.
So that is my alternative, but that would start, and in fact I'll go there now, right? So that would start with a foundation of well-defined preferences over the attributes themselves. Okay, so I'm gonna propose it and see if this is what you were talking about, right? So now suppose that every voter can tell me which gender they prefer, which party they prefer, which age they prefer, and they can give me a full ordering of preferences on all these dimensions. These can be conditional on the values of the other attributes. That makes our work harder, but we can certainly allow for that. And then we also need a rank ordering of the importance of these attributes. right? So which attributes are voters going to care about the most in making their decision? So if you have this prioritization of the attributes and you have the rank ordering of preferences within those attributes, then the voter can evaluate any two candidates and tell us which they prefer. Kind of a deterministic function of those things. That's one way to do it. Another is just write down a utility function. Exactly, right? So that utility function can contain the weight on each attribute, how much the voter cares about that attribute, and the utility they get from each value of that attribute. Right, and that's another way we can go. But both of these approaches require that the voter actually have some well-defined preferences over the attributes themselves rather than over the candidates. Okay, so these are some ways of thinking about it. So the next thing, right, we've defined preferences at the individual level. We're probably interested in preferences, summarizing preferences over a population of these people. So now we just have to aggregate up an average over people. So if you take my first approach and you like this feature choice probability, right, this proportion of contests in which the man over the woman is chosen, then you just average that thing over people, which gives you what we call the average feature choice probability. You can have an all else equal analog of that, right? So if we go back here, rather than averaging over all possible values of x1 here and x2 here, we can fix x1 and x1, y1 and y1, right? So that has another interpretation, but that might make sense to you, right? Like all else equal, will the voter choose the man or the woman? And then if you defined it our second way, if primitives are over attributes, then you can compute overall in the sample the proportion that prefers men to women. You can compute the average utility difference for male versus female candidates. You can grab that from your utility function, right? So it's straightforward to aggregate over people once you have a well-defined notion of these preferences at the individual level. Okay, so that was kind of the first thing I wanted to do, which is give you some options for how to think about preferences. And I'm happy to take a pause if there are questions on this, or I'm happy to move on to the next section. All right, so then I said in the second part of the talk, now that I've developed some notion of what we might mean by a preference, I want to talk about how that object corresponds to our causally identified quantities from our experiments. Okay, so I'm going to direct your attention back to this diagram, right? So I've been working over here on the left. I've given you some theories about what preferences look like. I've aggregated them up over voters. And now I'm going to go over here and take a look at what our research designs look like, what our estimands look like. Okay, so there's a large literature on whether there's bias against female job applicants in the labor market, right, or racial bias in the labor market. And a common way that people approach this question is through so-called audit experiments, right? So probably everyone's heard of these. So the researcher will construct identical resumes except for the gender of the applicant, and then randomly send one version to 50% or whatever you want of employers, and the male version to the other half. And then you can estimate the difference in the proportion of these resumes that actually get a callback, that actually get interest from the employer. And the idea is because you've fixed everything else about the resume, you've identified the causal effect of gender on the probability of being called back for a job. Right, so it might look like this. May I say okay? Yeah. You know, you might construct a resume like this for Stephen Nichols. You have a GPA, you have Stephen's education here. And then for the exact same resume, you might swap that out for a female name. This sounds pretty tightly causally identified, and it is tightly causally identified. But I'm going to show you that it doesn't correspond to preferences. So suppose you could observe all of the employer's preference orderings over there, and I'm going to say there are 3 relevant options here. And the 3 relevant options for us are the male version of this resume, the female version of this resume, and their most attractive outside option. So the person that they would have hired or called back in the absence of the intervention. And so let's say we have a sample of 3 employer types. So type 1 prefers the male over the female over the outside option. Type 2, the female over the outside option over the male candidate. Type 3, the outside option over the male candidate over the female candidate. And these are equally distributed, right? There's 1/3 of each of these employer types in our employer population. Okay, so first, let's just grab one of our definitions of preferences. Let's say straightforwardly, what proportion of employers prefer our experimentally generated male candidates over the female candidates? So type 1 prefers the male candidate. So we have 1/3. Type 2, the female candidate, and type 3, the male candidate over the female candidate, right? So overall, 2/3 of our sample prefer the male candidate over the female candidate. So what's the causal estimate that we get from this experiment? Well, the ATE is just going to be the probability of getting a call back given that you received the male resume minus the probability of a callback given that you received the female version. So let's compute that. Right, so in 1/2 of our sample that gets the male condition, I've grayed out the female candidate. Right, so let's see who gets or what proportion of this sample is gonna call back our candidate. So we have the male over the outside option here, outside over male, outside over male. So 1/3 of our sample calls back the male candidate. And then the other half of the sample doesn't get to see the male candidate, they have the female candidate. So type 1 calls back the female candidate. Type 2 also calls back the female candidate. Type 3 calls the outside option, so that's 2/3. Right, 1/3 minus 2/3 is -1/3. Our perfectly identified experimental estimate is -1/3 when 2/3 of the sample actually prefer men. Right, pretty wild. Like, what happened here? So, of course, we constructed this example to produce this reversal, but it's not so hard to imagine. It's an issue of preference intensity. Once more, it's an issue of preference intensity, right? So the candidates, or rather the employers who prefer the female candidate really prefer the female candidate over the outside option and the male candidate. The employers who prefer the male candidates tend to prefer both the male and the female over the outside option, right? So there's really a bigger difference here that drives the preference intensity. Now, this isn't always going to be the case, but what I'm arguing is that it's possible. And why is this, right? Well, because it's a commensurability problem. The quantity of interest and the estimand were not designed to be the same thing. So let's back up. Let's back up. Why are we doing causal inference here in the first place? Right? So we seek these causal quantities to get around the fundamental problem of causal inference. We can't observe both states of the world at the same time, but we want to see how outcomes differ between those two worlds, right? So this is our causal quantity of interest. But that's not quite what's going on when we're trying to measure preferences, right? Preferences are fixed, at least in this experimental setup that I gave you. there's nothing about the experimental intervention that is changing people's preferences. What's changing is the choice set that they see. Their preferences are staying the same, but they're facing a different choice environment, right? And why are we manipulating the choice environment in the first place? Well, it's not the usual problem of causal inference, right? That usual problem is we can't observe both states of the world at the same time. We're perfectly capable, in principle, of observing both these states of the world at the same time. We just have to send the male and the female version of the resume to the same employer. Now, there are practical reasons we don't want to do that. They're going to know we're up to something, right? In other cases, there might be social desirability bias. But it's not that usual fundamental problem of causal inference. There are kind of other reasons driving our research design. But I want to emphasize that what we're doing here is a little different, right? So usually we're interested in why some outcome is going to differ based on the treatment status. And what we're interested in and what we're doing in the audit study is we're measuring the difference in outcomes, right? This observed choice, which is a function of treatment status as well as preferences. But the preferences are what we're getting at, right? The preferences are what we're trying to measure. It's not the difference in choices for its own sake. Right, and so the point I want to make is that this causal quantity that we're measuring and the ultimate object that we're interested, preferences, they're not the same. We have to build a bridge. And measuring preferences is not inherently a causal exercise, right? It could be aided by an experimental approach, but it is fundamentally a descriptive exercise. We're trying to measure something that is not being manipulated by the researcher. And that's a really key difference. Right, so what do we do with this information, right? So we're going to propose a more unified approach, right? So we're going to propose, kind of given the first section and the second section of this talk, that you start with some model, you start with some understanding or some theory, kind of committing to some structure on what you mean by preferences, on what preferences are, how preferences translate into choices in a multidimensional setting. Some mapping between attributes and profiles. And then, you think about, is the causal effect for my experiment the thing of first order interest, or can I design something that actually gets at that object that is of first order interest to me? And we argue that kind of putting more structure on these preferences, while it might not feel good, right? While any sort of commitment you might make might feel wrong, right? A utility function feels restrictive. Someone will always come and say, that's not how people think, that's not how people form preferences. But the value is that you can get much more interpretability on the way out. This is kind of a side note because I'm not going to address it so much in this talk, although we do think about it in the book, is there are real problems of aggregation. So you might define this ideal quantity of a preference at the individual level. Things might get very complicated as you try to aggregate that up over a population. Social choice theory helps us out with that, but I'm going to bracket that in this talk. But then so now you have kind of your left side of that diagram. And how do you develop your research design to speak more directly to this? Well, we follow both the EITM and the sort of burgeoning TIEM traditions, right? So EITM, empirical implications of theoretical models, kind of says, put down a model, put down some structure, derive some empirical implications, and go test those implications. So that's going to be, so in the third part of the talk, I'll show you an example of how we could do that. The other approach is to go the other way, right? So we have all of this research that has now focused on the AMCE, right, or these kind of these ATEs from audit studies. And even though I've shown you and hopefully convinced you that they may not correspond to preferences, we could put some assumptions. We could add some further scaffolding and derive the assumptions under which they actually do correspond to some object that we care about. And that's the sort of TIEM, the sort of theoretical implications of empirical models tradition. And we do some of that work in the book as well. But today I'll focus on number 3. So writing down your model of preferences and directly targeting those parameters of interest with your design, with your experimental design. Okay, so I'm going to switch gears. Any questions about that section? Okay, so I'm going to do what I said we'll do, is write down a model, write down a utility function. We take inspiration from Wiswal and Zafar, their 2018 QJE paper. So we're going to say there's a unidimensional policy space, and voter I's ideal point is Xi in that one-dimensional space. We can define an ideological distance between voter I and candidate J. And that's just the absolute value of the difference between their ideal points. We're going to say candidate J also has some personal attributes VJ. So this can be gender, race, party, kind of additional personal considerations that the voter is taking into account besides this candidate's ideological stances. And now we need some weighting that voter I assigns to the ideological part and the personal part. So that's going to be RI to ideology and KI to these personal attributes. Some unobserved error term, and altogether our basic utility structure looks like this, right? So the utility that voter I derives from having candidate J in office is this ideological distance between the two, times the weight that the voter puts on ideology, plus the utility from personal attributes times the weight that the voter puts on that, plus some error. Okay, so that's the basic setup. And now we can kind of expand this further. We can introduce 2 different sets of considerations that the voter might have: instrumental and expressive. Right, so by instrumental, we mean kind of thinking purely about the strategic considerations of, will this candidate get into office and how will I benefit from this candidate actually holding office? By contrast, we also think voters derive some expressive utility from voting for their most preferred candidate. Even if they think that candidate won't realistically make it into office, there's still some value in kind of expressing your political preferences, expressing your support. And arguably, this is a lot of what voting is, because very rarely are voters actually pivotal. So now we can expand out this original utility function to just include 2 terms, the instrumental and the expressive concerns, right? So we still have D, the ideological distance, but now this is weighted by 2 things: the instrumental weight, RI, and the expressive weight, rho I. And then similarly for the personal attributes, there's an instrumental KI and an expressive kappa I. It doesn't look like we've done much yet, but these instrumental and expressive concerns are going to come apart in the next slide. They're going to come apart when we think about general versus primary elections. Right, so in a general election, probably these considerations point in the same direction. You should always just choose your most preferred candidate. In a primary election, there might be some strategic considerations going on, where on the one hand, you want to select the most competitive candidate against the challenger from the other party down the line, but you might also have your own preferences where you might prefer someone further on the left, for example, right? And so let's take a look at how that would play out in a primary election in our utility function. Right, so now, hopefully, I know this is a lot of parameters, but hopefully building it bit by bit helps. Right, so again, we have our ideological distance between the voter and the candidate. And now we're going to introduce Q, which is the probability that that candidate is going to beat the challenger in the general election. We're going to call that QJC. So now QJC is multiplied by Ri, the instrumental weight, but it's not multiplied by rho I because you get the expressive utility no matter what. It doesn't matter if your candidate actually beats the challenger. And then that structure is similar for V, for the personal attributes. Right, and then we have to add with 1 minus Q, the probability that then the challenger wins in the general election, and then you get the ideological distance to the challenger, and you get the challenger's personal characteristics, and then we still have some error term. Okay, so this is going to be the utility function that we're working with. Again, this is a lot of structure, right? These are a lot of possibly restrictive assumptions, but I'm going to show you the value that we're going to get from doing this on the way out. Okay, so I won't go into the details, but this follows a pretty standard IRT setup. So if you assume the errors are type 1 extreme value, we can get the log odds ratio for voter I's probability of voting for some primary candidate J over another primary candidate J prime. And so we're just going to do some algebra to this utility function over here. We're going to get this ugly thing over here. It doesn't really matter what this thing looks like. We're going to draw out the interesting parameters from this model. Right, so again, here's that hideous thing. But many of these parameters we can actually observe, either because we're going to design an experiment where we randomize those things and show them to a respondent, or because they're going to come from what the respondent reports back to us. And all of these red terms are in fact observable, right? So I'll just say what they are, right? So the P's are the probability that that the candidate will be selected by the respondent. That's going to be reported to us. Then we can randomly generate the candidate's electabilities, Q, their ideology, their personal attributes. These can all be part of the profiles that we show people. And then we ask respondents for their own ideological positions. That allows us to compute D, the ideological distance to any candidate. And we need their candidate choice, the probability that they will actually choose that candidate. So I'll show you what this looks like in a real experimental design. The point here is just for you to see that most of these parameters, or rather most of these variables are observable. And then in the green are the parameters that we have to estimate, which is not so bad. This is identified with OLS. Yeah, because all of these, because it's just one parameter here, one here, right? One for each of these observable terms.
You have a choice.
Say again.
You do have a choice.
A choice.
As a dependent variable. They choose between two candidates or not.
So I'll show you in the next slide. So I'll show you over here. So what they report is a probability that they vote for a candidate. Yeah, and I'll come back and I'll come back and talk about this in more detail. Right. So the point is that as ugly as this thing may seem, it actually we get to observe most of these things, and it's a reasonable number of parameters to estimate. We're not super interested in the parameters themselves so much as functions of those parameters. So the one really interesting function of those parameters, which again, I'm not going to walk you through the algebra, but we can get a willingness to pay for a personal attribute, such as having a woman over a man, for example, in terms of ideology, right? Because voters are trading off these things explicitly in a utility function. We can actually compute how much they're willing to give in terms of proximity to their ideological preference in order to gain some characteristic that they like, right? And that's actually a really nice measure of a preference, is how much you're willing to give up in terms of your ideology to get a man over a woman, right? So we can get that willingness to pay, and it's at the individual level, which is pretty cool. We can estimate this for each voter. So your willingness to pay for an attribute in terms of ideology, we can similarly do this in terms of electability, right? In terms of the probability that your candidate actually defeats the challenger in the general election. So we basically will run OLS, we'll get these parameters, we'll get the functions of these parameters that we're actually interested in, and we can get uncertainty using a block bootstrap. Okay, so what does this experiment actually look like? Right, so first, respondents will encounter, after a basic introduction, this question: where would you place yourself in the political spectrum? And they have a slider, and they can put themselves somewhere on this left-right dimension, and we give them some people that they're hopefully familiar with to anchor them on that scale. So this gives us our xi for every survey respondent. This gives us their ideal point. And then we're going to randomize the probability of beating the challenger, the gender, the race, and the number of years in politics. And in order to build up some sample, we can actually give them multiple candidates. Why not? We're not restricted to a binary choice, because we're actually going to ask them to report the probability that they would vote for that person rather than a binary choice. And we can use that as part of our outcome. And crucially, we also put these candidates on an ideological spectrum as well. So they're deciding over that as well. Okay, so then it's a pretty straightforward estimation task from there. Like I said, we run OLS, we get the parameters, we construct the functions of those parameters that we care about, block bootstrap to get the uncertainty. And again, we get this for every respondent, because if you give people enough of these questions, you don't even need to give them that many. The fact that we sort of get 4 observations per question helps us identify this. So this is what I'm going to show you is the willingness to pay for attributes in terms of ideology. And now we can actually look at a distribution of these things, right? We can look at this willingness to pay for every person. We can look at the median. We can look at the first and third quartiles. We can compute a proportion of the sample who prefer women over men, because that's just people who have a positive willingness to pay in terms of ideology, right? So this value could be positive or negative. If you're actually willing to trade something to get a woman over a man, then we can interpret that as a preference, right? So that's something we can compute in our sample. We find actually that there's a small preference for female over male candidates that is statistically significant. Nothing else here is statistically significant, which is actually consistent with some other recent work that has found this. Another interesting quantity, and this is nice, we can be kind of creative with the quantities that we can get out of this data, right? So another one might be the absolute value of this willingness to pay. in terms of ideology, right? Because the absolute value tells us something about the preference intensity, right? So how much you're willing to give up ideology in order to get your attribute of interest. And so this is kind of interesting, right? So even though female versus male was our only statistically significant result on the previous slide, our only sort of expressed average preference, we find that the preference is not so strong, like the intensity of this preference is not so strong. So the median here is 0.16. The third quartile is 0.4, and compare that to these racial characteristics. Black versus white, Asian versus white, these are much larger in magnitude, and we can interpret that as a greater preference intensity in one direction or another, because we've taken the absolute value, so we can't say in what direction here, but we can say that people feel more strongly about race than gender. Yeah.
Just a quick question on the interpretation of these numbers. So I understand that it's the willingness to pay for some descriptive feature in terms of ideology, but what exactly is the unit here? So
yeah, we've standardized it I believe between -1 and 1. You have to interpret it on the scale that you actually used.
Why did you use, if I get this correctly, you had, one particular label and then 3 generic labels for the name? I guess this was on purpose.
I'm sorry, where?
So there was Rick Scott, just this one.
Ah.
So you have Rick Scott, and this evokes, of course, other dimensions than only gender, race, and whatever.
Yes, sorry, I should have been clear. So this is our specific challenger in the general election. So we're allowing people to, so we're just kind of anchoring the choice in the kind of real life decision that they would make, and then these are the 4 that are actually randomized. And we don't give them names.
So this is the same for everyone.
This is the same for everyone. Yes. Okay, yeah, so I'm just gonna kind of weave these 3 sections together and give you some takeaways, and then I'll open it up for questions, because that was all I had to show you. But I kind of the takeaway from that last illustration was just how much we can do when we put some structure on these preferences on the way in, right? So I'll just read this part out loud because we really believe it. So we think beginning with an explicit model of how preferences translate into choices lets us design bespoke experiments to structurally estimate the theoretical parameters that you actually care about, right? You often encounter in the literature that something's non-parametric, right? And that's sort of described as a virtue. And that can be a virtue on the estimation side. It can also be a cost when you go and try to interpret that, as we've shown in past work. When, for instance, you can't interpret the AMCE as a majority preference, right? And here we can actually say something about majorities. We can say something about medians, quartiles. We can say something about individuals, right? We can sort of frame your preference in different ways. How much ideology are you willing to give up? How much electability are you willing to give up? These things hopefully align to some extent, but they could disagree, and that's interesting, right? So we get by putting down some structure, we get a lot back. The cost, of course, is that you have to believe that structure. Like you have to believe that model for any of this to work. But we do think that sometimes when you don't assume a model on the way in, you're just going to assume one on the way out, right? And we've shown this in our past work, where we've shown that the AMCE is actually just giving you an average ideal point. You didn't assume that coming in, but that's essentially what it's doing. So we encourage researchers to be a little more intentional about this, to start out with their model of preferences, to tailor it to their specific electoral context. You don't have to like any of the kind of definitions or measurements of preferences that I've proposed, right? It might vary based on your political setting, on voters' incentives, on the voting system, how votes are aggregated, which is another kind of set of hairy problems that I won't talk about today. But I'll end here and open the floor to questions.
Wonderful. Then we have plenty of time left for questions and answers. Also, those online, if you'd like to ask your questions, please raise your hand in the Zoom chat or post your question in the chat. Please.
Really not my topic. But I was wondering about the data that is produced with these kind of surveys and experiments or choice preference choice things. Like from a survey methodological perspective, for example, I think these like sliders from 0 to 100 are not ideal. And I was wondering, do you know of any research that has looked in like how measurement error and non-random error in the measurement process and in the data can affect the results and can influence your model and bias some of the estimates? Because you put a great deal of effort into like the model and the hypothesis and like getting from the theory to the model. But I wonder whether the whole thing blows up once you have issues with measurement.
Yes. Yeah, that's absolutely right. And it's certainly the case, like this assumption of a one-dimensional policy space is very important and certainly inappropriate for many contexts. I would argue it is most appropriate for the US, where I think if you show this to a voter, like, sure, many people will take issue. Maybe there are kind of two major dimensions rather than one, but I would say there's not really more. And I think this sort of one-dimensional space with names they're familiar with would actually look like a familiar problem in that context and not in others. I take your point generally. I think you're absolutely right, and there's certainly more careful measurement that one can do of voter ideology. And again, like you have to think about whether an ideological space even makes sense for your application. Like I think there are cases where respondents would reject that entirely, right? It's more about issues or something.
And I was also wondering, like, how much does it depend on the actual numbers that people put in? Like, if you could go back, to this slide, like, in the end, wouldn't it make more sense to use just the rank ordering of candidates? But as far as I understand it, you use the actual evaluations. Like you would use the score from 0 to 100 in your model instead of just whether somebody gives candidate A a higher score than candidate B. Is that right?
Yes. So that is in order to have this work over here. So I'm not sure how one would do this with rankings. And we're just following a nice design again by Wiswal and Zafar who did it this way.
Isn't this a demand function like in econometrics or economics?
Yeah.
Kind of, and if you have then those rankings, you have kind of a multinomial choice.
You have a multinomial. Yeah, no, you're right. So one could do it that way. Right. Yeah. That's a thought. Yes.
Also, thanks for the talk. I was also kind of wondering the same thing. Did you do any like analysis of how sensitive the scales are? So does it matter whether I put in like 25 or 30% for a candidate, or in terms on my ideological scale? Does it matter whether I'm like a bit more left of Obama or like 10 or 15%? Like, how sensitive is the scale?
How sensitive is the scale to,
On the results we get out, so whether people actually care about gender or race or.
so you're saying how sensitive if we move, like if we were to move these anchors around, or sensitive to?
Yeah, for example, if I were to be around, for example, from where I am now, like just maybe, I don't know, 5 point, like, yes, like that. Does that make it like a huge, does that make a huge difference for my results?
Yeah, I'm wondering how we would assess that counterfactual, because this is what is reported by the respondent, right? So I guess we could think about, right, rather than anchoring on like a very precise position, we could divide this into kind of sections of the scale. That would be interesting. That's probably something we can even do with our data. Yeah, I mean, like, to me, it seems like if you have the more fine-grained measure, why not use it, right? Like I would interpret the larger distances as sort of meaningful, and like I would interpret it as continuous. But I take your point that people might not have a very precise notion of where they are on this scale. So we could certainly kind of divide it up.
Yeah, that would like
Yeah.
my concern also, like looking up at these specific candidates, and I don't really see, but like between 57 and 51% or something. I wonder whether people really
Sure.
think about, okay, like 57 candidate, that's where I put my preference, and then 51, not so much.
Sure.
Something like that.
Yeah.
Whether, I don't know, whether it makes a difference whether I let them choose between 10 different categories or.
Yes.
I've also been wondering about, like, if you measured kind of ideology in a multi-party system as party preferences or policy preferences, would it work similar with like a vector for ideology? And if you give examples of like politicians like Rick Scott or others, did you control it all like for underlying policy preferences of the participants that they might connect to the examples?
Yeah, sorry. So I should have clarified this when I explained this slide. So Rick Scott is the challenger from the other party that they're going to face. So this we actually wanted to anchor in a real life choice that the voters would make at the ballot box. And then for these, there is no real. It's hard to extrapolate to policy beyond, right, from what's given here, which is ideology, gender, race, and years in politics. To your first point about kind of a multi-party system, yeah, absolutely. I don't see why not, right? Just think about the relevant dimensions and let people place themselves on those, and then compute a Euclidean distance or whatever.
Candidate like Rick Scott, that would be different from, like, it's like for the federal candidates, or like each for each state, like candidates.
Right. So this was a state election, but the same idea. Certainly do this at the national level.
Unless you also have a question?
Yeah. So I wondered, I love this. And it's kind of, somewhat surprising if people do lots of conjoints and suddenly come around and say, oh, maybe we should start thinking about theory again. So it's kind of cool. I like that. So I wonder, so, so the dependent variable, I'm not so sure about. So why did you try to measure utility directly, kind of? That's what you do. Why not just letting them decide which? Yeah,
I think
but then then we need to really sit down and think about whether we really want to model this as an OLS or
yeah.
or
Yeah. I totally agree. I totally agree. This was a choice mainly to build sample, right? So what this does for us, if you ask for these probabilities, is that it allows us to get 4 observations per person, per respondent, per question, which really helps with the estimation, because estimation is tough. Well, I was going to say with so many parameters, we don't have so many parameters, but it is much nicer to estimate this thing if you get kind of many bites at the apple here. If you asked for one choice, then you'd have 1 observation per question. But I take your point that it's not ideal from a substantive point of view, so it's kind of a trade-off.
Would you suggest, given that make such a good convincing case for theory, that if you don't measure the utility directly, if we may have choices, that we then also, people call this discrete choice experiments rather than conjoints.
Yeah. No, I take your point. I take your point. And so one could certainly do that. I suppose I don't think it's so far off to ask people about a probability that they would vote for a candidate, given that we're not giving them so much information, right? And maybe people do care about issues, and we're giving them nothing about issues here. So maybe it's sort of allowing people to extrapolate, or to allow for some uncertainty on the other characteristics that we're not reporting, and then to just give us the probability. But I agree with you. I mean, I would be interested to try this and see if we could estimate this thing with
Well, I guess it's more
free choice.
a personal frustration with the review process, because I am writing papers using discrete choice experiments since I don't know how many years, and have a willingness to pay in there, but reviewers don't like it. Run it as a conjoint, run OLS, and then we talk more. And I'm not willing to do this.
I should say this has not yet cleared review, so I don't know. Thank you.
Okay, cool. Nice.
Ollie, you had a question?
At the beginning of the talk, you differentiated between the EITM approach and TIEM. And as far as I followed, the experiment that you presented to us is in the EITM tradition. So you built your theory, and then you thought about an experimental design to inform the theory. And I imagine the other approach would be to now take what you learned from the theory to re-evaluate what we can learn from audit studies and conjoint studies. And at the very beginning, you said, well, oftentimes we may get misleading, or we get results and think that they mean something, although they mean another thing or something like that. But is there a more general lesson when we take your arguments and ask ourselves, what do they mean when we now encounter conjoint experiments or read results from conjoint experiments? What should we have in mind?
So, and I don't know, I don't know if my collaborators and I all agree on this. I think we do. I think we think that the TIEM thing is more of a second best here. We see that as our intervention into a literature that will likely continue estimating AMCEs and continue valuing non-parametric approaches, and we understand the reasons for that. And so we think we can also help by thinking about the conditions under which we can take those results and meaningfully interpret them as a preference. So the example that I didn't have, well, maybe I would have had time to talk about it, but I didn't include it here. Going back to the slide where I talked about the FCP. So this is a paper with the same set of co-authors and Anton Strezhnev, where so we define something called a feature choice probability, which I explained in this talk. And that turns out to be very useful as it's a very useful little building block for decomposing other things, right? So we can decompose the AMCE into a function of FCPs. And with that, we can actually say, well, under what conditions do the AMCE and these AFCPs, do they agree? And the condition, it turns out, is you need to impose some kind of transitivity on voter preferences, which, so I don't need to get into that too much here, but the point is, we can play this backwards game, right? Of starting with the thing that people are using, decomposing it into smaller pieces, kind of smaller, theoretically understandable, at least to me, pieces, and then using that information to derive some conditions under which we get kind of an intuitive correspondence. That transitivity condition is not, we find is often not satisfied. So that's a problem.
Next paper is published?
No, it is, we are submitting it like this week, but you can find a draft on my website. Yeah. Yeah.
I'd like to ask a follow-up on Ollie's
Yeah.
question. So by and large, I mean, given that there's probably a handful of people in this room who've done conjoints or are doing conjoints and now kind of worrying about what they can actually do with the designs they implemented. What would you say if we want to infer? So would you say the best approach is still doing what people do, focusing on the AMCE and just not interpreting it as a preference? And if so, what do we learn from it, in your opinion? Or do you think it's worthwhile exploring the plausibility of additional assumptions as the transitivity assumption that you just outlined, and still trying to the best of our abilities to interpret it as a indication of a preference?
Mm-hmm. So, and this is just maybe my taste, like I like assumptions on the way in. So I kind of like this approach of really thinking about your electoral context, thinking about what model you want to commit to in terms of how voters kind of think about the multidimensional problems they face and turn that into a choice. So I like, for me, that structure is part of doing the work. But I mean, I understand that this might be asking a lot of, and that the kind of then going and designing your own experiment based on that might be a lot to ask of practitioners. And I do see the value of many of us working with the same tools, right? So getting some comparability across studies. Yeah, I guess I will build on both sides, but it like to the extent that I do preference elicitation work on my own, I think my preference is to kind of put the assumptions down front and center and kind of make them on the way in. So yeah, and if your broader question is like, should people continue using the AMCE? I think under some assumptions.
Or
Yeah.
like, let's say if they already have the data from a conjoint, what's the best they can do with it?
Yeah. Yeah, I mean, I think if you don't have a ton of values of your attributes, and if you believe some version of transitivity, if you're not too worried about preference outliers in your sample, then AMCEs are okay. I would say like try to test for those things to the extent that you can. And yeah, so I like the FCP. I like it because we came up with it, but I think what I like about it is that it's this nice little building block, and you can actually decompose AMCEs and other things that people are using into this building block, which to me has a pretty intuitive interpretation as a preference. And so that's another thing that I would try, right? Is seeing how you're like, whether you're using the AMCE or whether you're using one of these other estimators in the literature, I would say like go and estimate the FCP. It's very easy. The problem is there are estimation advantages that the AMC has because it's using more data, it's using indirect comparisons, whereas the FCP is forced to use only direct comparisons. So that's why the AMC really has value. It's taking advantage of more data. But like estimate an FCP and like see what it looks like, compare them. I know that's you should do that once my paper's actually published, but working on it.
Of course.
Yeah.
I'd like to ask a second question. And you partly addressed it because you said that it's a lot of work to for practitioners to implement the EITM approach, derive their model, translate the model into a statistical model and corresponding research design. And I was wondering, given that you're currently working on the book manuscript, once that's out there, will it give like I don't want to call it a cookbook, but will it be some sort of a recipe for certain standard designs to allow practitioners to implement these things?
Absolutely, absolutely. That's the hope. That's the hope. And you know, this experiment that I presented built on other work, right? Like we didn't sit down and derive this model ourselves, right? We built on other people who use this for something else entirely, like for labor market stuff. But I think there's a lot of value, like there are a lot of these models out there that I think people haven't fully taken advantage of for political applications. And I mean, in fact, we took conjoints from the marketing literature, right? And marketing has, I think, relied much more on models, on structural models than conjoints subsequently. So so I think, we'll definitely try to do that in the book is maybe draw out some basic modeling structures from various literatures that people can use in political science.
Right, do we have any more questions?
Only thinking about the experimental design. I'm trying to think, so it's in a way it's still similar to conjoined experiment. It's really different, but it's similar.
Yeah, absolutely.
And I'm trying to think what the main design features of your experiment are that makes it different from conjoined. So one is that you have 4 comparisons, but as far as I understood, that's not the decisive thing. That's more like the reason is more that you want to get more observations. And then you have a different scale, so like the selection probabilities instead of a forced choice. And then I think as an implication of your model, you have the willingness to pay. And my feeling is that the willingness to pay component kind of is the crucial thing.
Yes.
This is correct.
Yeah, that's correct. So none of the design is radically different from a conjoint, right? Like it maybe looks a little different in form because we have these sliders, but ultimately we're randomizing attributes and we're asking respondents to report a choice. It's very conjoint-like in its design. I think the crucial difference, exactly as you say, is, well, you said the willingness to pay, but the willingness to pay comes from our willingness to write down a utility function, right? And so like one could even do a lot with standard conjoint designs if one is willing to write down a utility function.
Maybe just a quick follow-up on this experimental design, which I think generalizes to the question of using subjective probabilities as opposed to discrete choices. Are those sliders subject to a sum to 100 constraint?
Yes.
Okay.
Yeah, they automatically do so. Yeah.
And would you recommend doing that, or are there benefits to using an unconstrained subjective probabilities?
That's interesting. I don't know. I would spare my respondents from having to add or from or refusing to. I think probabilities should sum to 1. That's my view.
Makes a lot of sense.
Yeah.
Any more questions in the room or online? Anything else that you would like to to recommend for us as practitioners moving forward with choice experiments.
No, I think I've pontificated enough.
Okay,
Thank you.
wonderful. Then let me thank you once again. It was a very great. And this concludes the first event in spring 2024 of the MZES Social Science Data Lab, but we will be back in 3 weeks with our second event on March 13th, where Lydia Röpke from GESIS will teach a workshop entitled Survey Mastery, a deep dive into SQP 3.0 to enhance questionnaire development. Thank you all for being here and online. Thank you once again, Asya,
Thank you.
and we will see you all soon. Bye-bye.